Alright, chapter 4.1 to start our second quarter. Using graphs to relate quantities is the title of this. What is the purpose of this section? This section introduces to the concept of rates of change. It's a key idea in higher level mathematics in terms of analyzing graphs and equations. Be sure to take this lesson seriously, no matter how short or simple it may seem. There is not a lot of numeric algebra in this section, but it is a good amount of thinking. This is what algebra is getting you ready for. It is the thinking part that must take place. The graphs of this chapter will have an independent variable and a dependent variable. Independent variables on the horizontal axis, the dependent variables on the vertical axis. Remember, horizontal goes this way, vertical is this way. The variables will always be labeled on each axis, so just kind of keep that in mind. So when you're looking at a question like this, your two variables are time and volume. The title of this is air in a balloon, but this is your independent variable, and this is your dependent variable. Now, the thing that you're going to be doing is identifying rates of change that are positive, negative, and zero. Pretty much this part here, just to show you what you're getting into in terms of analysis. Time is obviously going to be moving forward. And volume, of course, is the amount of space. So amount of air in the balloon is going to start at 0. And as time goes, it looks like they're blowing the balloon up, so it kind of increases and then it stays flat. Well, why is it staying flat from here to here? Well, if you remember blowing up a balloon, this is probably where you're taking a breath. Sorry you can't read that, but I try to write really small. But again, it blows up. You go, you take a breath, and then you blow up again, and then you take another breath, and it blows up again, and you take another breath, and you blow it up again. And my question is, and this is what you have to analyze, why did the volume go all the way back down so fast, back to 0? And to me, it is because this is where the balloon, make sure I spell this right, because it doesn't really spell right if I do it the other way and put 2 O's. But that's where the balloon popped. Alright, so again, the balloon gets bigger, you take a breath. The balloon gets bigger, you take a breath. The balloon gets bigger, you take a breath. You blow some more, it reaches its max point, it pops, and the volume is back to 0. So again, you have to be able to analyze those things that are going on, and you don't need to do everything this deep, because the majority of them won't be this intricate, but you do have to be able to kind of look and think a little bit, put yourself in a situation, ask yourself, why is it increasing here and decreasing here? So copy these following sketches for rates of change. Positive rate of change is this. Alright. Negative rate of change is this. A way you can tell that it's positive is because if you wrote your name on this line, which I'm not going to write, but my name would go in an upward direction. That is positive. It's moving up. The way I know is if I wrote my name on this line, it's going down, which makes it a negative rate of change. So if it is going this way, it's positive. This way is negative. Going back to this. This is a positive rate of change. It's increasing, and then flat, and then increasing, then flat, then increasing, flat, increasing, and then all of a sudden decreasing because it's going down. So again, just keep all that in mind. Your zero rate of change is flat. Now I don't know how I can draw a flat line, but again, it should be just a flat like the ground. Just like when the person was taking a breath and it went straight across, it did not change. A slow rate of change would be something like this, or this. A fast rate of change is something like this, or this. Again, common sense will tell you how to deal with this. How do I know it's a slow rate of change or a fast rate of change? If I'm trying to get to the top of a 5-mile mountain, and it's 5 miles high, and I'm walking this hill, will I get to the mountain faster walking on this line or this line? Obviously this line will go faster because it gets up faster. Same thing, if I'm walking down a hill, am I going to move faster going this way or this way? And obviously that is a fast decline versus a slow decline. This is a slow increase because remember it's positive. If I put my name on it, this is a rapid increase. So you got to kind of keep that in mind. And changing rates of change are this. It starts out like this and it curves and does something like that. In other words, it's still increasing because notice that it's constantly moving up, but it's moving up slow, a little bit faster, a little bit faster, a little bit faster until it's eventually moving up very quickly. or something like this, to where it's dropping really quickly, slowing down, and almost not going forward at all, to where it's almost flat, because remember, flat is 0. So those are your key ideas for rates of change: positive, negative, slow, 0, slow, fast, changing. You don't have to use all of them today, but you should at least understand it if you see it in terms of what's going on. Alright? The last part of your lesson today is in comparing graphs to tables. This skill requires a more common sense than anything else. A linear function is a function with a steady, consistent rate of change. Its graph looks like a straight line. Moreover, its rate of change is the same for each step. If a function is not linear, then it has some sort of curve. Alright? Match the graph to the table. So here we go. The best way to do this is with common sense. First off, this is linear. Looks to me to be pretty straight. But let's look at these rates of change. This is 7, 9, 11, 1. So that's going the same. And this is going plus 1 here, plus 1 there, plus 1 there. Remember, if it's linear, it's going to have a constant rate of change. So that should be a line. That could be it. Let's look at this one. This is plus 2. This is plus 6. This is plus 15. I don't think that's going to happen because that would be curving. Again, linear means it's the same. This means it should not be straight. And then here, using common sense, this is going down 4, down 1, and then back up 9. Is this going down at all, based off what we know? Is that a negative rate of change from here to here? Nope, it's positive all the way through. So this tells me it can't be this one. The fact that these aren't the same tells me it can't be this one. Has to be A. Alright? There is not a final thought, but there is something you want to kind of keep in mind. Two things that I did not put in your notes that I'm putting in now. You might, or you will see these on your homework, and all that it's going to do is give you 2 pictures. So write these 2 pictures, and this is called describing the graph. Let's say that this is hours, and this is weight. And so those will be your variables. And you want to make sure that you understand these 2 things, because all it's going to say is to describe the relationship, and this is what you're going to write as this one here. Then it will always increase, because your independent variable will always move this way. So as hours increases, comma, and you have to type it that way because you have to type the whole sentence, as hours increases, weight does what? Is that a positive or negative slope? It is a positive slope, which means that weight also increases. So that will be one thing you have to actually type into your computer as a sentence. Not all caps, of course. I think you can get away without capitalizing anything at all, just as long as you have as hours increases, weight increases, because some of you are going to put the wrong variable first. You will always start with your independent variable, because your independent variable will always go forward. So as hours increases, weight increases would be one of the ones you'll see. Let's make up another one. Days. I don't know how to spell. Sorry, messed myself up. Days and money. Doesn't really matter. The key idea is that you'll see a graph that looks like this, and so all you'll be asked to do is put as days. Again, this will always go forward. Increases, comma, because it's 2 sentences. What does money do? Is that a positive or negative rate of change? Looks to me to be negative, so that means money decreases. So again, that's what you're looking at. If you have any issues with that, please again email me. Just make sure again, if there's any work involved in your email, which for this section it's not, that you at least show me your work. But again, general idea here: analysis is the key ingredient to making math easier. Be sure to think your way through the information. It will start off a bit awkward, but again, as long as you practice it and take it seriously, you will get better as you practice the thinking portion of the problems. You have less to do in the week now, which means that if you fall behind, it means to me that you really don't want to be here, and that you probably do not really need to be in the class at this point. But like I said, make the most out of this week. Make sure you keep up with everything. You have a quiz coming up Friday. Remember, it needs to be done Monday, but here is the written notes that I discussed here, just so you can kind of copy those down if you want to. Don't forget to answer the question at the end of this section, or at the end of the video, because that is your grade. Other than that, good luck.